Okay. Square root of negative numbers. What do you know about that? What's the square root? Okay, let's start. What's the square root of 9? Just plain old 9. 3, right? What's the square root of negative 9? Yeah, it's not real, is it? Right? Because, how would you explain the square root of 9 is 3 to a person who'd never done square roots before so that they could then do them? You'd ask what? If they said, why is the square root of 9 3? You would tell them, don't bother me, kid, just do what I say. No. You would say 3 times 3 is 9. Exactly. You'd say, what number times itself is this thing, huh? That's what square roots do, right? So likewise with negative 9, what number times its very self will be negative 9? Nothing. No way to do that, huh? Because you can't have positive 3 times negative 3 because that's not times its very self. That's times its opposite. And you can't have 2 negatives because 2 negatives would be positive, not negative 9. It's just impossible. You can't, so the square root of any negative number is not real. In fact, we say it's imaginary, don't we? It's not real, it's imaginary. Right. And now we'd like to do some imaginary math.
Oh, we're doing imaginary
math. We're kind of out of real math at this point. So we're just going to start doing imaginary math. I'm not kidding. So square root of negative 5, what we're going to do, it's going to be very easy. It's a little weird, but it'll be very easy for you. Whenever you've got a negative inside of a square root, instead of saying it's not real, it is not real, we're going to use our imagination. And we're going to say, take that negative and bring it out and call it I. And you're done. That's all they want. Take that negative, slide it out, and put an I in front. What do you think that I stands for?
Imaginary.
It really does. Imaginary.
The imaginary root of 5.
That's right. Yeah, what happened to math is real and all that kind of stuff? Yeah, we'll talk about it. It's easy.
The negative I.
So we got negative, the square root of negative 18. This negative on the outside, he's just negative. Don't do anything with him. He's there. He'll be there to the end. He's nothing fancy. What do you do about the negative on the inside, though? Bring him out as an I. That's the whole section. Negatives on the inside, well, there's a little more to it now, but that's the main part of the section. Negatives on the inside of the root, slide him out. All right, now what about that negative that's already out there? He's still out there. We don't care about him. He's nothing special. Good so far. Then we got to simplify the root of 18. But is everybody good so far?
So the negative just turns into an I, imaginary?
Yeah, the negative inside the root turns into an I outside the root. Yeah, let me write that. Negative inside the root comes out as I. That's the fundamental rule of the section. Because negatives in a root are not real. They're imaginary. So you take them out and you put an I. And now you know how to simplify root 18, right? What times what's 18? 2 times 9. 9 3 times 3. So you know the drill. 2 3's inside. Still do all the normal stuff. Yeah, all the normal stuff is still.
Is it still going to end up being negative?
Yeah. Yeah, that negative that's out here, that's just because of this negative.
So it's
Negative 3i.
Negative 3i. Root, what's left inside? 2. There we go. Negative 3i root 2. Does that make sense?
Do they make this kind of math?
We'll get there. We'll get there. Let's just make sure you can do the mechanics first off. Is that good mechanics? So really, all I did different than stuff we've already done is the negative inside kicked out an I. That's the only new part. The rest is regular. Root of 18, 2 3's in, 1 3 out. That's all old stuff. The only new part so far is negative in a root, kicks an I out of the root. The rest is regular. So square root of negative 144. So what do you do when you see a negative inside a root? Kick it out. It's an I.
I-12?
And then just do square root of 144. What's square root of 144? Calculator will tell you.
12.
Yeah, so you can say I times 12, or you can say 12 times I. The order doesn't matter. Never matters. I 12, 12I, whatever. It's the iPhone in 20 years.
Oh, no.
Is that good?
It would be the iPhone 12 in like 2.5.
So it's just normal, huh? The only new part is negatives in a root. Okay, so square root of negative 25 plus the square root of negative 500. Can you do that one? So just take those negatives right away, kick them out. I. So it's I root 25, no longer has the negative. We kicked it out as an I. Plus I root 500, no longer has the negative. We kicked it out as an I. And now you know what the square root of 25 is. Just 5. I'll make it 5i. You can make it I5. It doesn't matter. Now 500. Can you break down the 500?
Yeah.
5 times 10 times 10.
5 times 100, and yeah, the 100's 10 times 10. I would just stop right there. I wouldn't go 2, 5, 2, 5, because as soon as you see a pair, ship it out. 2 in, 1 out, right? Just ship out a 10 right there. So it'll be 10i. What's left inside? That 5, root 5. So it's 5i plus 10i root 5. Done. On that, yeah.
I entered the equivalent of that on mine, and it said it wasn't done. Like, it said the answer was right, but it said it still needed to do more.
Huh? Maybe you're right. Maybe I'm... All right, we good to there? That good? Yeah, so thanks for the heads up. They want you to factor out the I. Is that all good? All right. I'll move on. Let's see. All right. 7 minus 7i plus 7 minus 5i. These are called now complex numbers. They're complex because they have both a real part and an imaginary part. Doesn't it seem like we're just making this up as we go along?
I feel like you are.
It just seems like it, doesn't it? Well, maybe, and I just don't want to use up too much time. 1 minute, and I'll keep to that. Is math real?
Yeah. No.
Right. Good. You remember the answer. Math is not real. So if you're looking at these imaginary things, going, Mr. Heron, they're not real. I'm going to go, yeah, none of math is real. None of it. Not just the I. 3 is not real. We think, yeah, I saw 3 people. Well, yeah, 3 people are real. 3 cars are real. But threeness, the math concept, the pure math idea of threeness, is a made-up math concept to describe things that are real, yeah, but in itself, threeness itself is just made up, right? You with me? You understand philosophically? We get a little philosophical for a minute? All of math is made up, remember? Not just the I. All of math is made up, right? To describe things that are real, but math itself is made up, right? Remember my example was sound? Right, decibels. Oh, how long? I can't sing, but how loud a sound is. Right, the sound doesn't know how many decibels it is. It doesn't say I'm 47 decibels. It doesn't. We made that up to describe sounds to help us deal with life, and on and on you go. Well, I is made up as well. It's all made up. We didn't just start making it up now with I. It's all been made up to describe things that are real. So if I was you, I'd be thinking right now. You telling me, Mr. Heron, that I, the imaginary thing, describes things that are real? Absolutely. Absolutely. I don't have time. I'm looking at that clock. I could, but I'm not going to. In 5 minutes, maybe I'll do it next time. Type into Google, put up here, real life uses of imaginary numbers or complex numbers. You can do it at home. Maybe I'll take 5 minutes next time. And all kinds of, I actually did them at Cal Poly, some engineering applications. They use it for circuit design. Anyway, enough said. Absolutely. This is absolutely usable. And it's not the only thing that's made up. All of math is made up, including the I, to describe things that are real. Remember, all of math is made up, but we use it to do real things. All right, enough said. We better move on. So this is made up too. It's all made up, but they do use it for real things. This is called a complex number. It's got a real part, like 7. You can have 7 erasers or whatever. And this is the imaginary part. You can't have 7 I erasers, right? So you have a real and imaginary part, and this has a real and an imaginary part. Right? Well, a number that has both real and imaginary parts put together into one number we call a complex number because it's not simple. It's complex, has a real part and imaginary part. So we have this whole new made-up construction called complex numbers. And they make up this whole world. They did. They made it up, just like I'm saying. They made up this whole world of numbers called complex numbers. And then they made up rules for how you add complex numbers, how you subtract complex numbers, how you divide complex numbers, how you multiply complex numbers. And we'll now do that in the next 6 minutes. See what we can do. It's actually very simple. If you had to make it up, what would you make up for how you add 2 complex numbers?
I would just leave the I and subtract as usual.
Wouldn't you say, just take the real part with the real part? And the imaginary part with the imaginary part? That's exactly it. Just like terms. It looks just like terms. It's exactly what it is. 7 and 7?
49.
14. We're just adding here, right? There's a plus sign in the middle. It's not times.
You don't know.
Don't be thrown off by those parentheses. There's a plus sign in the middle.
So it's not like.
It's not multiplying.
Where you multiply?
It's not like, what's that?
Like distributing where you multiply?
We would never multiply with a plus sign in the middle of anything,
This is so
right?
I don't
So
know.
if that.
Wait. Okay, hold on. If I gave you this with no symbol in the middle,
Boils.
that would be multiply. But if I put a plus in the middle, it's not multiply. It's 1x and 1x is 2x. 1y and 1y is 2y. Remember, parentheses do not always mean multiply. They never have. They only mean multiply if there's no other symbol in the middle, right? So we clear on that rule, which has always been the rule? So the parentheses don't mean multiply here either. They never have, they never will, when they have a plus sign in the middle. Right? So that plus sign in the middle means this is an add problem. So 7 and 7 add to be 14. Minus 7i and minus, what's that, 5i?
Yeah.
Make minus 12i, and that's it. Isn't that what you'd expect? Just like that? Add them,
Combining like terms.
Just combining like terms. That's all it is. Combining like terms. They're weird, but they're pretty easy. So 7 minus I, subtract, right? This is subtraction, right? Not multiply. Even though there's parentheses. Parentheses only mean multiply if there's no other symbol in the middle. So those are subtract. What do you do when you got a minus in front of a parenthesis? Distribute. Totally. Yeah. Just like always.
But, so you don't,
Just take that, go boom and boom.
like how you did positive?
I do what I would always do with a minus symbol. Like, what if I had 3 plus x minus 2 plus 7x or whatever?
So-
That minus would distribute, wouldn't it? Be minus 2 minus 7x? That's all I'm doing. Just what I would always do with a minus in front of parentheses. Yeah, just do like terms. Just treat the I like an x, you know? Totally just like terms. 7 minus I minus 9 minus 7i.
Negative.
Is that good? 7 minus 2 is negative 2. Minus I minus 7i is minus 8i, and we're done.
Could you factor that? Did you put it in there?
Oh, yeah, they don't, though. They want you to write it a plus bi. So, yeah, let me explain the a plus bi. They want a real part and then an imaginary part after. So that's what a plus bi means.
Are they picky about putting the I in front of the B or the 8 or whatnot?
No, I don't think.
Because this past 6, was it 6, 7 or 6, 6? They were kind of picky on where you put the letter.
You have to show me what you mean, Abraham. But I'm pretty sure they will take this just like that. On that. Good on that. All right, maybe we should stop there. You guys look like you've had enough for the day.